Hi everyone. So today here we are going to take how to find limits involving infinity. So here how to find, that's what our goal for today here. How to find limit x close to infinity for f of x, or limit x close to minus infinity, x close to minus infinity for f of x. I need to get the limit of this. So what I mean, x close to infinity, what will happen for your f of x? Close to what? Your f of x close to what? Or when x close to minus infinity, your f of x close to also what? What I gave you before, x close to c. X close to c, here c is finite number. Finite number. What do you mean finite number here? Finite number means could be positive, real numbers, it could be zero, it could be positive, it could be negative. And then for this one, you must get here left limit, x close to c from the left, x close to c from the right. But here for infinity here, infinity plus infinity or minus infinity, they are not numbers. They just tell you x close to plus infinity, very big positive number, x close to minus infinity, x close to very big negative numbers. And here, I've just tried to show you here, okay, sorry, here. All right, so that is here, just try to move here, all right. So if you have x, here is your x here, right? So if I go x close to plus infinity, that's a plus infinity. So x is still be positive and keep continue very, very, very big. That is when you have x close to plus infinity, right? So that is when x close to plus infinity. So when I have here x move in this direction, then x close to minus infinity, because you have very big negative numbers. So now let me give you example here, guys, how to find this one here, but maybe I give myself a room here so that I have, okay, all right. So here, try to see where is the mouse here. All right, so here I try to see where is x close to infinity. I'm just trying to give myself room so that I can write here. All right, so here, all right, so here, all right, I'm just trying to see. All right, there's not writing here, so I don't know what happened here. All right, so it's now start writing. I'm just giving myself a space so that I can write. So that's what I have here, right? So you have 10 pages here. So my apology here for this one here, but so that is when I do online. Always you have some kind of problem here. So I go back here. So here, let me give you example here, guys, where you have. So let me show you by example number 1 and see what you have here. Example number 1. All right, and I have to find the limit x close to plus infinity, and here you have 6x squared minus 3x plus 1 divided by 2x squared plus 4x minus 9. All right, so now I need to take the limit of this. First, I have to give you, I gave you before two methods. One is called numerically and the other one is called algebraically. What is numerically here? What do you have? X close to plus infinity. Like for what? For example here, what is your f of x? Here is your f of x. That is my f of x, right? So that is our f of x. So I should write here f of x equal just the fraction here, which is 6x squared minus 3x plus 1 over 2x squared plus 4x minus 9. So that is my f of x. So now when x close to plus infinity, it's a very big positive number. You could take x equal 1 millions, or for simplicity here, for simplicity, take x equal 10,000. Here 10,000 or 1 millions is just to give you 1x equal very big positive number. What happened for your f of x? F of x equal what? So here I want for you to use technology with me. If I write 10,000, then you have 10,000, right? Minus 3, 10,000, right? Plus 1, the whole thing divide 2, 10,000. I'm just replace x by 10,000 square plus 4 10,000, right? Minus 9. Then what happened here? You go ahead and use technology, guys, to so what you are going to get, you get maybe 2.999, something like this. But in a way, you get something. This number is close to what? Close to 3. So if you take 1 million, you will get, instead of 2, how many 9 you have here? 3 9, 2.999. If I take 1 instead of 10,000, I take 1 million, maybe you get 5 or 6 9, which means it will be very close to 3. So now what is the limit of this one here? The limit, it will be limit x close to plus infinity, and then you write just the function here, which is what you have there, 6x squared minus 3x plus 1, the whole thing divided by 2x squared, right, plus 4x minus 9, and that is equal 3. What does this mean? When x very big positive number, this your f of x here, that is my f of x close to 3. You get 2.99, which is close to 3. Here again, as you don't have left limit or right limit, because x is close to plus infinity in one direction only, and plus infinity here is not a number. Just to tell you, it's a very big positive number, okay? That is called numerically. Here, if you take 10,000 or 1 million, you can figure out. So now what I'm going to do algebraically here, I'm going to give you 2 ways for algebraically here. In the exam, you have a freedom to do whatever you like. So what is the problem here? I need to find x close to plus infinity of, just copy the function here, which is 6x squared minus 2x, right, plus 1, and divided by 2x squared plus 4x minus 9. So if I try to get the limit of this algebraically, now let me ask you guys, here you have a fraction, that is the whole thing, your f of x. If I look to 6x squared minus 2x plus 1, look what you have up. 6x squared minus 2x. What is this one? It's one polynomial. Yes, polynomial. Polynomial of degree what? Polynomial of degree 2. Polynomial of degree 2. What is my leading term, guys? What is my leading term? My leading term here is, we'll call it 6x. What is the leading term? You look to the highest power. What is the term here? X. Oh, your unknown x, but the highest power is x. The highest power for x is 2, and then the leading term here, the whole thing, 6x squared. So you look to the highest power, which term has highest power, and include the number in front, include the sign. If you have 6x squared, then you write 6x squared. If you have negative 6x squared, then you should leading term should be negative 6x squared. What about this leading term? When I say x close to plus infinity, say for example here, if I take x equal 1 million, all right, 1 millions, like you take x here equal 1 millions. So what happened for this term? This term will be 6x squared, which is 1 million square, minus 2, and here 1 millions, and here plus 1, right? Plus 1. So if you look to this term here, what do you have for the first term? That's called leading term. It will be 6 10 to the power 12. How many 0? Here you have 12 0, and here minus 2 millions. 2 million here is 2 million plus 1. Plus 1, that's nothing there. So if you have a very big positive number like this, if you take out of this 2 million, then what will happen? This one here, can I say this one here almost 6? It will be the same, like 10 to the power 10. It's almost the same, because 2 million out of these very big numbers, it's almost the same. Does not affect. Like if I have $1 million, if you take out of $1 million 100,000, then what do you have? When you have 100,000 out of 1 million, we can say almost your $1 million should be almost the same $1 million, except 100,000, which does not significant. So that is called leading term. Is going to be dominate here. Dominate means is going to lead the whole term, the whole polynomial that I have, 6x squared minus 2x plus 1. This one here it will be almost 6x squared. That is only when you have x a very big positive number. All right, that is called leading term. So here I will do the same also for the other term here, leading polynomial. So this one, it will be almost, you see, almost, because I'm neglecting other term. is not significant. This, what is significant term here? Significant term here is your leading term. The other term is not really significant, so I can take it out. So this one, remember, when you work in limit, means when x close to infinity, remember infinity is not a number. It could be 1 million, it could be 1 billion, it could be 10,000, very big positive number. How big, we don't know, but this f of x, the whole fraction, will be close to a specific number as soon as x is very big. If you take 1 million, you will be this fraction, your f, close to specific numbers, very close to specific number. If you take x equal 1 billion, 10 to the power 12, for example, then you will have closer to a specific number. So this one, what is your polynomial up here? 6x squared minus 2x plus 1. It will be almost, if I take a limit here, x close to infinity, I'm going to consider only the leading term, 6x squared. So the other term is not significant. It will not show up because your 6x squared will be very, very big. 1 million square, it will be very big. If you take out 2 million, is nothing, does not affect about the significant numbers here. So likewise down, if I look to down here, this one, what is the polynomial that you have? The polynomial that I have here, where is the row here, and maybe I change the colors. All right, so what do you have here, the red here? If I take whatever I have down here, 2x squared, 4x minus 9. So what is the leading term? It will be 2x squared. So what is the leading term? You take the highest power, which is x squared, includes the number 2x squared. So now that is almost, so which means I can simplify now. X squared cancel with x squared. So if I simplify this, 6 over 2, what did you get? 3. 6 over 2 gets 3. What is the limit? Any constant should be exactly the same constant, right? So here, what did I end up? I end up limit 6 over 2, which is when x is close to infinity. So that's a constant, it will be 3. That's called algebraically here, guys. So that is exactly what I got here when I did numerically. Look what you have for the numerical part, you get 3. Right? When I have algebraic one, you get also 3. So now that is called algebraically. So you take, that is, remember, when x is close to plus infinity or x is close to minus infinity. If you have x close to c, finite number, I cannot apply this. I cannot apply this. It's only apply when x is very big positive number or when x close very big negative number. All right. So now I have to recall some fact before I give you more problems. What is the fact here? The fact, limit x close to infinity 1 over x to the power n. What this one? It will be 0. But why? Some people can ask. X close to plus infinity means, say, for simplicity, take 1 million, which is positive 1 million. So now if I have 1 over x, guys, 1 over x, and x equal 1 million, what this one here? It will be 0. 1, you can use technology. 1 over 1 million, 1 over 1 million, you get 0. Almost 0, right? So now, what happens if you have even 1 over x squared? 1 over x squared, it will be 1 million square. That's 1 over 10 to the power 12. 1 over 10 to the power 12, which is almost 0. So here now, if you have 1, what is your x here? X to the power 1. You get 0, almost 0. When you have x to the power 2, you get 0. Likewise, if you have x to the power 3, also you get 0 when x close equals, say, 1 million. So now 1 over x to the power n, but in the positive number, then what did you get? You get 0. That is a fact. So I'm going to use that. 1 over x to the power n, you get here 0. That's, I call it fact number 1. Now, what is the fact number 2? Fact number 2 here, if you have limit x close to minus infinity for 1 over x to the power n. X close to minus infinity, that is also give you 0. But why? X close to minus infinity means x a very big negative number. Very big negative number. For example, you take x equal negative 1 million. Negative 1 million. So now, if you have 1 over x, what is your x here? 1 over negative 1 million. So what this one? You can use technology, you will get 0. But why is 0? Because negative sign here, what is negative sign means? It's a negative 1. It's a negative 1. I can grab it out, it's a negative 1. And here, what do you have? You have 1 over 1 million. So this term, if I use technology, you have 0. 0 multiplied by any number, you get 0. So now if you have even negative 1 million, if I have 1 over x square, then what do you have? You have 1 over negative 1 million square. You can use technology, negative square, you get 1 over 10 to the power 12, which is 0. So what is the factor number 2? When x is close to minus infinity, 1 over x to the power n, where n here a positive number, you get 0. Right? So your n here is positive, just a positive number. This one here means positive number, writing in short, positive number, your n positive number. So this factor number 1, factor number 2, I could apply this. All right, so now I need to let us solve what is the example that I gave you before. Solve, I ask you limit, the same example here, but I need to solve it in something different, another way. We still call it algebraically. 6x squared minus 3x plus 1 minus here 3x plus 1, down you have 2x squared plus 4x minus 9. So now I need to solve another way here. I look to the up here, that's polynomial. Up, down you have another polynomial, so it's a fraction, polynomial divided by polynomial. So when I look to up here, the first one up, what is the highest power I could have for x? Oh, x squared. The highest power, x squared. Then I'm going to factor out x squared. Grab x squared out, factor out. Why? Because that is the highest power. So when I factor out x squared, means each term inside I should divide it by x squared. Each term I should divide it by x squared, right? 1 over x squared. Down here, what is the highest power down for this polynomial here? That's polynomial of degree 2. The highest power again here by accident, x squared. So I factor out the highest power. I look for x. What is your x? The highest power, or x squared. I factor out this. When I factor out this, what did you get here? You have limit x close to infinity. Then what do you have down here? You have each term divided by x squared, because I factor out this. So you have 2x squared over x squared, 4x divided by x squared, minus 9 over x squared. Simplify. How to simplify here, guys? Oh, x squared cancel with x squared, right? So this one, it will be limit x close to infinity. X squared cancel with x squared, you get 6, plus 1x cancel with, what is 3x divided by x squared, you get negative 3x, negative 3 over x, plus 1 over x squared. The whole thing divided by, down here, what do you have? X squared cancel with x squared, you get 2. Here, 1x cancel with x squared, you get 4 over x. And here, minus 9 over x squared. Right? You are taking, what do you have in the middle here, guys? You have in the middle minus, plus, minus, here plus, and here minus. So if you have in the middle minus or plus, then I should take the limit of each term. X close to infinity, for each term, you have 6 minus limit 3 over x plus limit 1 over x squared divided by limit each term 2 plus limit 4 over x minus limit 9 over x squared. Remember the limit here, x close to plus infinity. So now I take the limit of each one. What is the limit of any constant, guys? The rule that I gave you last time, limit x close to infinity for 6, that's a constant, should be the same. What is the limit of 3 over x? 3 over x, I can grab 3 out. 3 out of the limit. So what you have left, if I take 3 out of the limit, you have 1 over x. Recall here, if one of the property I gave you when I say limit, if you remember, constant multiply by f of x, what do you have? You can grab the constant outside, and you grab the constant outside of your limit, and then what do you have? Limit of your f of x. That is one of the rule I gave it to you last time. And also the fact that I gave you up, when you have plus infinity 1 over x to the power n, what do you have? You have 0, right? So here, if you take 3 out, what do you have left here? 1 over x. So from the fact here, 1 over x to the power n, what is 1 over x when x is close to infinity? This one 0. What is 1 over x squared? 0, because if you take n is 2, you get 1 over x squared. When x close to infinity, you get 0. You can see that x like 1 million, as I mentioned, 1 million square, you get 0. What is the limit of constant 2 here? Divided by 2, that's a constant. Limit of any constant should be 2. What is 4 over x? That is 0. 4 over 1 million, you get 0 when you use technology. Here, negative 9 divided by x squared, like 1 million square, you get 0. So what did you get here? You get 3. And that is exactly similar to what I have up. I give you using approximation leading term, and I give you numerical way. All this example here, when I give you the limit, you have a freedom to use what you have there. Okay, you have a freedom to use what you have there. So now I'm going to give you another example here, guys. What is another example that I am going to give you? I give you the fact here, 1 over x to the power n. So maybe I give you another one here. So example number 2, if you have, I need to find limit, right? 9x plus 2 divided by x squared minus 4x plus 7. That is your f of x. What is your limit when x close to plus infinity? When x close to plus infinity. So what I'm going to do here is, that is polynomial divided by another polynomial. So if I take the limit, it will be limit x close to plus infinity. So what is my leading term? What is do you have up here? 9x plus 2. 9x, what is the highest power for x here? 1. 9x plus 1. So what is my leading term up? So look what you have here. This notation means approximated. I'm going to give approximations, because when you work in the limit, means it's close to a specific number here. When x is close to infinity, the whole fraction close to this question mark here, which is a number. So how close? That is what I try to figure out. So 9x to the power. So the leading term up, just 9x. Leading term, which means the term has highest power, include the number in front, which is 9x. When I look down, what is polynomial here down? This polynomial is x squared. So what is the leading term down here, guys? It will be x squared. If I simplify this, it will be limit 1x cancel with 9x, so we have 9 over x. And where is x here close to? Plus infinity. So so 9 over x. What is when x close divided by, say, 1 million or 1 billion? So what do you have? You get 0. 9 over x, you get 0. So, or you can grab 9 out. That's a constant. I can grab it outside of limit. So what do you have inside? 1 over x. What is your x? Close to plus infinity. So 1 over x here is, if I take, according to the fact I mentioned to you, 1 to the power x here up. What is the fact here? Look what you have. This fact here, you could take x equal 1, you get 0, right? You get x equal 1, you get 0. So this one here, 0 multiplied by 9, you get 0. So what is the limit here? The limit here is 0. All right, I give you another example here. If you have limit x close to plus infinity, x squared plus 5 divided by x plus 2, x squared plus 5 over x plus. So now, what is my leading term here, guys? My leading term is x squared. What is the leading term down here? What is that? The highest power, x. So you have x, your x close to infinity. So if I simplify this before I take the limit, you get x squared over x, which is x. What is x close to infinity? So what did you get? You get infinity. You get infinity. All right, you get infinity. So now I have to give you another example, which is maybe harder than what I give you. Remember, if I repeat the same story for the same example here, limit x close to minus infinity, and here you have negative x squared plus 5, and here you will have here maybe 2 minus x. All right, 2 minus x. So now if I take this limit here, guys, what is your x? Your x is close to minus infinity. Close to minus infinity means you could have very big negative number, like minus 1 million. So what is the leading term up? Oh, the leading term up is negative x squared. I look to the highest power, which is 2, but I include the number in front, include the sign. Oh, and you have negative x squared. That is my leading term. Now, when I look down here, what is my leading term down? Oh, it's negative x. The highest power is x to the power 1. That is my leading term. Include the number in front, so you have negative x. If I simplify this, negative x cancel with negative x. What do you have? Oh, you have x. you have x, and here x close to minus infinity, so you will have minus infinity. When x is close to minus infinity, what is your x? Your x here is minus infinity. Look what you have, negative over negative, you get positive. 1x cancels 1x, you get x. But x is close to infinity, then you must get minus infinity. All right, so now I give you another example here where you have to give attention to this. If you have limit x close to minus infinity, x close to minus infinity, what do you have here? 16x squared minus 3 divided by 2x plus 5. 2x plus 5. All right, so now I need to take the limit of this one. Here you have a square root, it's called radical square root of 16x squared minus 3. So how to do this numerically, guys? Numerically, just try to solve it here. Numerically, x close to minus infinity. For example, here take x equal negative 1 millions, or negative 10,000. It will be this is okay too, because I'm doing numerically. So what is your f of x? Your f of x is the whole fraction here, the whole thing, which is square root of 16x squared minus 3, the whole thing over 2x plus 5. That is your f of x. So now what happened if I replace f by negative 1 millions? So when you have square root 16 minus 1 million square minus 3, the whole thing divided by 2, and here 1 millions plus 5. I don't have the technology here, guys. That's 10 to the power 6. You go ahead and use technology for this to get which number you are close. So this one here, it will be close to the if you use technology for this one here, remember it's minus 10 million, so you have minus sign here, minus. So if you try to use this one here, you get almost negative 2. Yeah, I don't have my technology, but you maybe get negative 2.000, negative 2.0. I forget how many zero here. I don't have technology with me, so you have almost negative 2. You can check which number, but what I really care, it's a number close to negative 2. That is called numerically here. And always we learn there is numerical technique for complicated ones. But now if you try to use algebraically here, let me show you how to use algebraically here. So how I'm going to use leading term. All right, so leading term here. So look, you have your f of x down here. What is the monomial? So if I take limit x close to minus infinity, I should tell you x close to minus infinity. I'm just telling you x is what? Is negative number. X is negative number. So what is my leading term here, guys? That is the highest power 16x squared. So it will be my leading term 16x squared. Then I'm going to neglect negative 3 because it's insignificant, because your x here is very big numbers. So like 1 million. So if you have 1 million square, negative 1 million square, then you have 10 to the power 12, and negative 3, it's nothing there. If you have 1 billion and you take negative 3 out, then does not affect the number here. That's called dominated term. Down here, what do you have your leading term down? Oh, 2x. Here we have to be very careful here, guys, because 16x squared, some people think that 16x squared is nothing but is 4x. No, let me show you here what is we have to recall, or have to remember. X close to minus infinity. Here you have square root of 16 multiplied by square root of x squared divided by 2x, right? So let me show you here. I separate here. Is that correct? Negative 16 multiplied by negative x squared. Here we have to recall, guys, from high school or from other, if you have a square root of a square, that will be not a. Is not a, but absolute value of a. That is the definition of absolute value. If you have this square root a square, it will be absolute value of a, which could be a positive if you know a is greater than 0, and negative a if you know a less than 0. All right. So here x squared. What do you know about x? Oh, x close to minus infinity. X close to minus infinity means your x is negative. less than 0, we'll say here negative. This one, in short, instead of writing negative, or just maybe I should write negative. Negative means here I'm just write negative minus VE, which is negative. If I write plus VE, means positive. So here, guys, I return back to this problem. What is square root of 16? You get your limit x close to minus infinity. Square root of 16 is what? Is 4. Square root of x squared should be absolute value of x. Absolute value of x divided by 2x, by 2x. But what is absolute value of x here, guys? The absolute value of x, it could be positive or it could be negative, depend on x. What do you know about x? Close to minus infinity means it's negative. So instead of absolute value of x here, I am going to replace that by negative. So you have here 4. I'm going to replace absolute value of x by negative x. The whole thing divided by 2x. Right? Why I bought the absolute value of x by negative x? Here is the definition. Absolute value of something. It could be positive, it could be negative, depending on the whatever inside the absolute value. Whatever inside the absolute value, if it's positive or negative. So here, I know x is negative because close to minus infinity. So simplify this. X cancel with x. 2 cancel with 4. So what did you get? You get negative 2. So I have here limit x close to minus infinity of negative 2. Limit any constant should be the same constant. Limit any constant should be the same constant. And that is what I got here. Look what you have. When I did numerically, what did you get? You get something close to negative 2. And here I'm doing the same, x close to negative 2. All right, guys? So that is very much summary what I give, how to find the limit infinity here. So, but now let me solve more example here so that I can wrap. So more exercise here. I try to calculate, try to find. It's very important to justify for me. Do not give me the answer I don't know from where. So you have x squared minus 3x. If I try to take the limit of this. Now, what is my leading term here, guys? What is my leading term here? The leading term is the highest power, which is x squared. What is your x? Your x close to plus infinity, or could be plus or minus. Could be plus infinity or minus infinity. So if you have plus infinity, like 1 million square or minus infinity squared, then what did you get? You get plus infinity. So the result here, it will be plus infinity, right? Plus infinity. Another example here, guys, x close to minus infinity, x close to minus infinity, and here you have negative x squared minus 5x plus 1 over x plus 3. All right, over x plus 3. So now how to handle this? So what is my leading term? You see, that's almost these approximations here. Limit x close to minus infinity. What is my leading term here? Oh, negative x squared. What is my leading term down here, guys? X. If I simplify this, you have x close to minus infinity, negative x squared over x, you get negative x. Negative x. What is x? X close to minus infinity. So if you take minus 1 million, but you have negative x here, negative x. So if you replace x by negative 1 million, minus infinity, we have minus here, minus. So what did you get? You get plus infinity. You get plus infinity. Right? Is that okay? You have plus infinity. All right, guys. So I give you another example here, guys. What do you have? Limit x close to infinity, x squared plus 5x over 2 x squared minus 1. All right. So what is my leading term here? X close to, remember, I'm just repeating myself. When x close to plus infinity or minus infinity, and when you take the limit, x close to plus infinity or minus infinity, that is the one where you take the leading term. You get this approximation only when you have x close to plus infinity or minus infinity. So what is my leading term here, guys? The highest power, x squared. Down, what is the leading term here? 2x squared. So x squared cancel with x squared. So what do you have? X close to infinity of 1 over 2. X squared cancel with 1x squared. So you have 1 over 2. That is the constant. What is the limit of any constant? The limit of any constant here should be the same, which is the same constant. Limit any constant should be the same constant. All right. So here I think that is where you have x close to infinity. So maybe I'm still solving some example here. So if you have limit x close to infinity, that's one of the problems in the textbook, 2x minus 4 divided by 3 minus 2x. All right, so x close to infinity. Then I can take the leading term, which is limit x close to infinity. What is my leading term here? Oh, 2x. What is the leading term down? Leading term includes a sign. It's negative 2x. So now x cancel with x, 2 cancel with 2. So what did you get? If I simplify, you will get negative 1. Negative 1. So what is the limit of any constant? Again, is it will be the same constant. It will be the same constant, right? So if I solve another one, another example here, that is number 28 in the textbook. So you have limit x close to minus infinity, 2 over 4x minus 1 cube minus 1 cube. All right, so how to get this one here? All right, so here, look what you have, guys. What is my leading term here? The leading term here is, what is the leading term up? So leading term x close to minus infinity. Remember, x close to minus infinity, it's a very big negative number, like minus 1 million. So you have 2 divided by 4x. 4x here, if I expand, what is this bracket? The bracket here is a bracket multiplied by itself 3 times. So I take 4x to the power what? 3. 4x to the power what? 3. And the other term I'm going to neglect. So that is my leading term. So if that's a bracket multiplied by itself 3 times, I take only the first term to the power 3, and then the rest I will neglect. So now if I use technology to get this one, can you guess what did you get? You will get 0, right? I'm going just recall here, if you have limit x close to plus infinity or minus infinity, 1 over x to the power n, you get 0. Here 4 to the power 3, it's a constant. You can grab the constant out. You can grab the constant 4 over 4 to the power 3. So what is inside the limit? You get 1 over x cube. 1 over x cube. The constant, you don't need to worry about the constant, because limit 1 over x cube, when x close to minus infinity, you get 0. This one 0. 0 multiplied by any number, you get 0. You get 0, right? If you follow, guys, here. So now I have to give you another one, and then I can wrap this one here. What is another one? Another one here is number another example here. You have to be careful. What is the one here? Another one here is when you have limit x close to negative 1, 3x cube minus x squared over 2x plus 1. All right, so here I don't have plus infinity or minus infinity. If you don't have plus infinity or minus infinity, all what I give you in this lecture here, I cannot apply, because I cannot take leading term. I cannot take leading term. So how I'm going to handle that? That is what I gave you last time. How to handle? Just replace x by negative 1. Replace x by negative 1. If I replace x by negative 1, what do you have? You have negative 3. You have replace x by negative 1, you get 2. And here replace x by negative 1. Right? Simplify this. Negative 1 to the power 3. What do you get? You get negative 3. Here you have negative 1. Negative 1 squared, you get plus 1. But in the middle, you have negative. Over negative 2 plus 1, you get negative 1. If I simplify this, right? So you have negative. So here you have negative 4 divided by negative 1. So what did you get? You get 4. You get 4, which is, that is our limit. That is our limit. All right. So I want for you here just to only you take the leading term if you have plus infinity or minus infinity. If you don't have that, then you don't need to do that. All right, guys. So that is very much here what I give today here. We could solve, but I think I will very much the idea here. I'm just are repeating ourselves. So I think I will stop here, guys, and we continue next class. All right. Thank you. All right. Have a good one.